Welcome back to my YouTube channel. In today's video lesson, I'll be solving different practice questions that cut across different topics in chemistry, specifically for the JAMB exam. So let's get into the first practice question, which is, if an element X of atomic number Z and mass number Y is irradiated by an intense concentration of neutrons, the relevant nuclear reaction is... Now, this question is very easy. When you see questions under this aspect, your mind should go to a topic in chemistry called radioactivity. What they are asking us to get here is getting the correct nuclear reaction for this question according to the information provided for us. Now, let's solve together. It is very easy. Now, if you check first, they said if an element X, okay, that element is X. Please watch. This is how I will solve it. This is the element X of atomic number Z, okay, and mass number Y. Now, in your introductory chemistry, atomic number for a particular atom that is unknown, or all atoms in chemistry, atomic number is located down. Please note this, because we are trying to know this X now. Atomic number is located down. This is what I mean, class. Atomic number Z. So Z should be here. Do you understand? Because in introductory chemistry, we have something like this. X is equal to A and Z as well. Do you understand? So I don't talk more about that. Just focus. I said atomic number is located down and mass number Y. Mass number is located up. Do you understand? So they said mass number was Y. Do you understand? So this must be noted. So we form the element X. So if an element X of atomic number Y and mass number, atomic number Z and mass number Y, we've gotten the information. This is the representation of this we just read. Is irradiated by an intense concentration of neutron, meaning that neutron, which is a subatomic particle, but in this topic, neutron is a radiation, okay, but specifically a minor radiation. I have video lessons that explains the introductory aspect of the topic radioactivity, so it's important for you to go watch that video lesson. I'm going to put the link to the video lesson on my description so you can be able to watch it and understand the basic rudiments of radioactivity. But listen carefully, you'll be able to solve this question. So this is the atom we formed, or the element. So then I told us that this element was what now? Irradiated, was exposed to a radiation, which is neutron. Okay, neutron is a radiation. But we cannot say, okay, plus neutron. We cannot write that. We have to know the symbol for neutron as a radiation. Neutron is symbolized as this N, 1 and 0. That's how neutron is symbolized. I believe you are following. So the next thing we do, let's say that the relevant nuclear reaction or nuclear equation is, so this is something we must note. So we are trying to form what should be here. Do you understand? We are trying to form our product. This is the reactant side and also this is the product side. So how do we do that? Very easy. Just know that what you are having up and what you are having down, you are adding them together. Please note what I just said. What you are having up and also what you are having down, you are adding them together. And the way it works here is this is just a radiation. What we are interested here is this particular element, okay? This particular element is what that will appear at the end. So this is what I mean, class. So write it again. So look at, write it again here, X. So what did I say we add? So Y plus 1, that's what we have to have up here. So Y plus 1, whereby here becomes Z plus 0, okay? Z plus 0. And you already know that Z plus 0 is nothing. Do you understand? Because that 0 is out already. So this, class, is the correct nuclear reaction of this question given to us. So let's look at our answer. Let's look at the answer we've got in and try to get the option that this answer is in. So class, is this option A? This reaction, does it correspond to option A? Not at all. Check. It does not correspond. It corresponded up to this part, but this is wrong. Okay, option B, let's check together. Here is Wow, we've gotten the answer. The answer to this question, class, is option B. Do you get? Because you can see that here was just Z, which you can also make this to B. Okay, this is already out, where option C can never be the answer as well. So the answer to this question is option B. I believe now you understand how to solve questions under this aspect. So let's get into the next practice question, which is question number 2. Okay, guys, moving further, for question number 2, it says, if a gas occupies a container of volume 146 cm cube at 18 degrees Celsius and 0.971 atm, okay, its volume in cm cube at STP is what? That's what they asked us to get. This is very easy. This is under gas law, but specifically which of the gas law? It is the general gas law or general gas equation, because they gave us 3 parameters. Okay, when I see that, I'll know that, okay, this question is on the general gas equation, because class, this here is volume, okay, this here is volume, this here is temperature, and lastly, this here is pressure. Pressure is expressed in atm, mmHg, as the case may be. So this is volume, but specifically, what volume was this? It was my first volume, so it is V1. Okay, now before we talk about that, what's the formula for the general gas equation? It is P1 V1 over T1 is equal to P2 V2 divided by T2. So this 18 atm should be called, is it time? No, it is temperature. So this is T1. We'll talk more on this. Please take note, whenever you're solving any question on the gas laws, your temperature must always be converted to absolute Kelvin by adding 273. So temperature in degrees Celsius will be converted to what now? Kelvin. So how do you do that? You say Kelvin is equal to degrees Celsius plus 273. So Kelvin will not be equal to 18 degrees Celsius plus what? 273 Kelvin. So what do we have? 18 plus 273, that is 291 Kelvin. So this should be the temperature that should be here, or it's at T1, whereby this is our P1 as well. They not say that its volume. That means they are asking us to get V2, okay? They are asking us to get V2 in cm cube at STP. So what's the volume in cm cube at STP? So we have to understand some very important information. First of all, you have to know what STP means. STP means standard temperature and pressure. So what is standard temperature and pressure? That's what they ask. What's the value for standard temperature? So all of these should be ascribed to my tools, in the sense that here becomes T2 and also P2 as well, because they asked us to get the volume at standard temperature and pressure. So what is standard temperature? What is standard temperature value? You have to know this. It is 273 Kelvin. What is standard pressure value? It is 1 atmosphere. Now, the reason I did this was, please, everybody note this. Now, you can see that the initial pressure they gave to us was in atm. That was why standard pressure was still expressed in atm. So for instance, they gave us this pressure, the first pressure to be in mmHg. Let's say they gave us 500 mmHg. Please listen carefully. Let's say they gave us here to be 500 mmHg. What becomes this P2? 760 mmHg. You know, we have standard values for pressure. Standard value for pressure can be 1 atm, can also be 760 mmHg. So because the initial they gave to us was in atm, that's why I had to use 1 atm. If it was the mmHg, I'll use 760. I believe it's clear. So the next step here to solve this question is to make what we are asked to look for subject or formula, which is V2. So making V2 subject, we are having V2 will now be equal to P1 V1 T2 with times each other. We'll now divide by what now? P2 T1. It's very easy, times like this. So P1 V1 T2 divided by what now? P2 T1. So let's impute our parameters into the formula and get the answer to the question. Is very easy. Okay, guys, what becomes P1? What's P1? The first pressure, 0.791. What is V1? The first volume, 146 cm cube times. What is T2? 273 Kelvin. So here becomes 273 divided by what is P2? 1 atmosphere. And what is T1? 291. Okay, so altogether, what becomes V2, which is second volume? We are having 0.971 okay, times 146 times 273 divided by 1 times 291, that is 132. That is 132.9969 cm cube, which is approximately 133 cm cube. So what becomes the answer to this question, class? Option A. So you can see how questions under this aspect are being solved without stress. Very easy. So let's get into the next question, which is question number 3. It says, metals of the first transition series have special properties which are different from those of group 1 and group 2 elements because they have what? Now, whenever you hear about transition metals, they have special properties due to they have partially filled d orbitals, and these properties can include them forming colored ions, okay, them forming complex ions. Do you understand? They have the ability to act catalyst. Do you understand? These are some special properties of these elements due to they have partially filled d orbital. Now for 4, it says dash discovered atomic number. Atomic number was discovered by a scientist called Henry Moseley. Okay, Henry Moseley, whereby dash discovered cathode ray. Cathode ray was discovered by a scientist called Williams Crook. So all of these must be noted. So let's go over to the next practice question. Okay guys, let's get into the next practice question, which is question number 6. And from the look of things, this particular question is on IUPAC nomenclature. That means they are asking us to name this compound, and to do that is very easy. What I want from you, I want you to watch closely to every step I'll be taking to solve this question, because at the end of solving it, you will be able to solve it when you see it in the exam hall. So please listen carefully. And if you are new to this channel, you haven't yet subscribed to this channel, do well to click the subscribe button and also share these lessons with your friends, because it will help them greatly. So let's progress to solve this question. So the first thing in naming organic compound is that you have to identify the longest continuous carbon chain. Now, what am I trying to talk about? Now, you have to look at the compound and look at the part that has carbon-carbon-carbon connection. So you now look at the one that is the longest and identify it and pick it out. Do you understand? And in the look of things, I can see that it is only in the horizontal direction we had carbons connected together. So that becomes the longest continuous carbon chain. So I've identified that. You can see I'm drawing. I want to put it in a box so that it will be easy for us to understand. So the next thing we do is to number the longest continuous carbon chain. Are you getting me now? So how do we number the longest continuous carbon chain? Now you have to number in the direction so that the functional group of this compound is favored. Now what's functional group? Functional group is that atom bond, do you understand, or a radical that tells us the chemical property of that particular compound. And in the look of things, the functional group of this compound is the OH functional group, called the alcohol functional group, specifically alkanol functional group, meaning that the name of this compound should end with a null. Do you understand? But I said that the functional group of this compound is an alkanol, okay, or alcohol. Let's just call it an alkanol. So the ending name of this compound should end with a null. Do you understand? So that's for that. So let's number. And now we have to number in the direction so that our functional group gets a lower number. So what do you think I should do? Should I number from here to here or number from here to here? Since we already identified this to be the functional group, I have to number from here to here, meaning that it's going to be 1, 2, 3, and 4. Do you get? I can number from 1, 2, 3, and 4. If I do that, my functional group will get number 4, and which is not the rule. The rule says you have to number the direction so your functional group gets the lower number. So the number for our functional group now is just what? 1. Our functional group is seen in carbon 1. But if we number in this direction, our functional group will be seen in carbon 4, which is not allowed here. Do you understand? So that's for that. After numbering the longest continuous carbon chain, you have to name it. So in the look of things, how many carbons do we have? We have 4 carbon. Do you understand? You know, anytime we have a 4 carbon compound in organic chemistry, we call that a bute. Do you understand? We call that what? A bute. But since it's an alkanol, we simply call it butanol. Do you understand? We simply call it what now? Butanol. So that's for that. So you can see that we have other groups attached. And at carbon 2, we had chloro. We had chlorine. But in organic chemistry, you don't call it chlorine. You call it chloro. At carbon 3, we have bromo. So what do we do to name this compound? It's actually very easy. So follow closely. So you can see that at carbon 2, we have chloro. So I will call it 2-chloro. At carbon 3, we have bromo. I will call it what? 3-bromo. Do you understand? Now take note. Between numbers and letters, we use dash to separate them. Do you understand? So that's for that. And the parent name should end with, or the parent name is what? Butanol. So how do we name this compound? Very easy. Now, to name organic compounds, you have to make sure that your substituent follows the alphabetical order. Now, B and C, which one comes first? B. So B should come first. So it's going to be 3-bromo, 2-chloro, last name, butanol. Now, this must be noted. Between, I said that between letters and numbers, we use dash to separate them. So you can see how it works. You can see the name of this compound. This is the name of this compound. It's actually very easy. So what we've gotten, let's check if it's in the option. So we had 3-bromo, 2-chlorobutanol. So let's check. We had 3-bromo, 2-chlorobutanol. The answer is option B. Do you get? So that's how it works. It's actually very, very easy. So let's get into the next practice question. Okay, guys, the next question says the radioactive radiation used in studying the arrangement of particles in giant molecules is actually called the X-ray. Please take note. Not this is gamma ray, this is alpha ray, this is X-ray, and this is beta ray or beta particle. Okay, if you call it, you can decide to call it ray or particle. Do you get? So the answer is option C, called the X-ray. Now, looking at question 8, it says the alkyne that will give a white precipitate to silver nitrate or silver triazonitrate 5 specifically is what? Now, please take note of this. The alkyne that gives positive test. So what they're asking now is the alkyne that responds to silver nitrate is what? And the color change becomes what? White. What's the alkyne? We have different type of alkyne. We have terminal alkyne, median alkyne, conjugated alkyne. Please take note. Option A. Now, I'm just saying alkyne. What's an alkyne? An alkyne is an hydrocarbon with a triple bond. So, first of all, let's eliminate. Do you think option C will be the answer? No, it can never be the answer, because you can see we saw a what now? A double bond. Sorry, a single bond here, and we said that for you to be an alkyne, you must have triple bond. So the answer is going to be between option A, B, and C. But take note, it is terminal alkyne that gives positive test to trioxonitrate, which is silver trioxonitrate. And how do you identify a terminal alkyne? You can see the word terminal. It means that the functional group, the triple bond, should be at the end. Terminal. Do you understand? So there is the answer. Do you understand? Option B, the answer, because you can see that triple bond was found in the last carbon. Okay, here the triple bond was in between. Here the triple bond was also in between. So this is the answer to question option D. Very easy. So question number 9 says Lucas reagent is used to test for alcohols. Please take note. This is the reagent that you use to test for alcohols. Now for question number 10, it says the percentage of water of crystallization in ZnSO4.7H2O is what? Now this compound, first of all, is called green vitriol. Do you get? It's called green vitriol. So they're asking us to get the percentage of water of crystallization, and to do this is very easy. You just apply a formula and solve. It's actually very easy, so pay attention. So we'll solve it together. Okay guys, so what's the formula we use to apply to solve this question? It is percentage, they're asking for percentage of water of crystallization. So percentage of water of crystallization. Now looking at this compound, where is the water of crystallization? This is the water of crystallization. Do you get? So what do we do? It's very easy. It's solved by saying the molar mass of water of crystallization divided by the molar mass of the full compound, which is what? ZnSO4.7H2O, which I will explain, times 100. Do you get? Because we're looking for percentage, we always times by 100. You can see the answers and in the form of percentage, so we times by 100. So the next thing we do is to divide this compound. Here is the compound ZnSO4.7H2O. So this is part of water of crystallization, and everything is a full compound. So first of all, the first thing we do is to calculate the molar mass of water of crystallization, which is what now 7H2O. Now this is how you do it. Please, you bring it out the way it was written in the question. Okay, if there was 1 million H2O, you write it like that. If there was 2 H2O, you bring it down. So what becomes the molar mass? Very easy. They've given us the atomic masses. So molar mass, I'm using the symbol mm as molar mass. Hope it's clear. So the next thing we do, we'll now say write 7 again, and we'll solve the molar mass of water in a bracket. Hydrogen atomic mass was given to be 1. So hydrogen is 1. How many hydrogen do we have in this question? 2 times 2 plus oxygen is what? 16. So the next thing we'll now say 7 into, I believe you know that 1 times 2 is 2, and 2 plus 16 is 18. I believe this is clear. So what becomes 7 times, bracket means times. So what becomes 7 times 18? That is 126. So here become 126 grams per mole. So 126 gram per mole is the molar mass of the part of water of crystallization. So let's solve for the molar mass of the full compound now. Okay, so how do we do that? It's actually very easy. We write it, which is ZnSO4.7H2O. So let's calculate the molar mass of the full compound. So it's very easy. So molar mass will now be equal to, what's the atomic mass of zinc as given in the question? It is 65. So right here as 65 plus, what's the atomic mass of sulfur? 32. So right here as 32 plus, what's the atomic mass of oxygen? 16. And how many oxygen do we have? 4. So please, this dot you are seeing here, signifies plus, addition. So we are to add. So what did we get for our 7H2O? No need to calculate again. We had 126. Do you understand? So that's what we got for the 7H2O. So let's add 65 rather, plus 32 plus 16 times 4, that is 161. So 161 plus 126, that is 287. So we're having 287 grams per mole to be the molar mass of the full compound. Do you understand? So let's impute. So what becomes the percentage of water of crystallization is going to be molar mass of water, which is 126. Write it up. 126 divided by molar mass of the full compound, which is 287. So 287 times what? 100. So what becomes our answer? So we're having 126 times 287. Sorry, 126 divided by 287 times 100. That is 43.9%. 43.9%, which is approximately 44%. So let's check which option has 44%. Is option B. So option B becomes the answer to the question. It's actually very easy. So let's get into the next practice question. Meanwhile, if you are just joining this community and you haven't yet subscribed to this channel, do well to subscribe. I have so many video lessons in chemistry and also in biology that will help you improve greatly. Okay, so let's get into the next question. Okay guys, let's get into the next practice question, which is question number 11, and it says an acid salt has, so they are asking us to tell the property of an acid salt. Now it must be noted here that for we to call a salt an acidic salt, we'll say that that salt will have hydrogen ion in its aqueous form. Do you understand? Or in aqueous solution. So we have examples of acid salt like the likes of NaHCO3. This is an acid salt or an acidic salt. Why? Because of the presence of what? Hydrogen ion. So if there is no hydrogen here and there is OH replaced, for instance, okay, but it does not work exactly the way it is now, you just know that that particular salt is a basic salt. Do you understand? This particular question is on the topic acid, base, and salt. If you have hydrogen ion in that compound, or if you have hydrogen ion attached to a salt, you say that salt is an acidic salt. But if you have hydroxide ion OH attached to a salt, you say it's called a basic salt. So let's get into the next practice question, which is question number 12. And it says, dash is a greenish yellow gas and it turns blue litmus red and then bleaches it. It is actually chlorine gas. Okay, that's Cl2. This must be noted. Now, question number 13 says the gases that are used majorly in Fountain's experiment. There are two gas. The first one is ammonia, NH3, and also HCl. These are the two gases that are used majorly in the Fountain's experiment. Now, question number 14 says, the process whereby an acid is used to remove rust from metals is simply called pickling. This must be noted. Whereby for question number 15 says the catalyst used in the production of trioxonitrate 5 acid is, now trioxonitrate 5 acid is this acid which is HNO3, okay, HNO3. This is the acid, trioxonitrate 5 acid. If I don't have to write acid at the end, I will write first hydrogen trioxonitrate 5. Do you understand? But if I don't write hydrogen, I'll put acid. So that's the point. So the catalyst is platinum rhodium. This is the catalyst used in the production of this compound, which is HNO3, and it is done by a process called a Hostward process. Okay, it's done by a process called the Hostward process. Okay, this must be noted. So that's for that. That's the process used to produce this guy, which is HNO3. Now, another question, which is question number 16, says the coal mainly found in Nigeria is called lignite, and lignite can also be regarded to be called brown coal. Okay, brown coal. Now, question number 17 says the oil for graphite is called plumbago. Okay, oil for graphite is called plumbago. Now, question number 18 says the test for calcium metal gives dash flame brick red. This is a JAMB question. They've asked it before. Please take note. Okay, the test for calcium metal gives what flame? Brick red flame. Okay, now question number 19 says 400 cm cube of a gas diffused through a porous pot in 2 minutes. Calculate the rate of that gas X. Very easy. Now, what's the formula to which you calculate rates? Now, this particular question is under the Graham's law of diffusion. So rate here is calculated using the formula volume over time. Volume over what? Time. You just divide, you do. Very easy. So what's the volume? Because they're asking us to get rate. So what's the volume given in the question? 400 cm cube. And what was the time given in the question? 2 minutes. Now, please, it's very logical. Look at your options. Are you not seeing the unit of the answer? Cm cube per seconds. Slash. To have more understanding about chemistry calculations and solving all of this type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAMB exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen. It means pair. Do you understand? CM cube, that means it tells you that the time in this question should be converted to seconds. Time was a minute. So how do you convert minutes to seconds? You times by 60. Do you understand? So it's going to be volume, which is 400 cm cube over, what's the time? The time is 2 minutes, but we can't use it like that. We have to convert to seconds, which is 2 times 60. That's 120. So we have the 120 seconds. Okay. So we now have 400 divided by 120. That is 3.333 seconds. Sorry. Centimeter cube per seconds. So the answer to this question becomes option B. I believe it's clear. It's actually very easy. So let's get into the next practice question, which says the catalyst used in hardening of oil is nickel. Okay, this is whereby oil reacts with hydrogen, okay, to form margarine. Margarine. Do you understand? And the catalyst is nickel. Okay, so the next question says 21, which says the catalyst used in Haber process is called finely divided iron. Finely divided iron. Okay, it is iron. That's a catalyst. Okay, the reason why iron is used as a catalyst for Haber process is because iron is a transition metal. And remember I said in this video that transition metals, they have special properties due to them having partially filled d orbitals. Not just acting as catalysts, they also form complex ions or complex compounds. Now, for question number 22, it says this compound is called, this particular compound is IUPAC called hydroxybenzene. Okay, IUPAC called hydroxybenzene. Why did I call it that? Very easy. But commonly, it is called phenol. Okay, there are reasons to all of these names. Now, this alone without the OH is called benzene, and OH attached is called hydroxyl. So when we put them together, we call it hydroxybenzene, but commonly it is called phenol. Okay, that must be noted. So for 23, it says stainless steel is an alloy comprising of, now alloys, they are the combination of a base metal with all other metals. So here the stainless steel is formed together by some metals which include iron, chromium, and also nickel. All of these are the elements. They are all metals, but specifically they are transition metals. Do you understand? So all these must be noted. So let's get into the next practice questions. Okay guys, let's get into the next practice question, which says what volume of 1.5 moles per dm cube of KOH, which is potassium hydroxide, K is potassium and OH is hydroxide, so when you bring them together as potassium hydroxide, would contain 0.045 moles. Okay, that's the question. It's actually very easy. When I see questions like this, my mind will go to the topic mole concept, which is one branch of stoichiometry. Okay, it's actually very important as a JAMB aspirant, a science student to be precise. You must be grounded in the topic stoichiometry, and that is why I've made it very easy on my channel. So the video lesson on how to solve questions on stoichiometry will be on the link up here, so you click on it and go watch it. It's actually very easy. Okay, let's solve together. Now when I see moles, my mind will go to number of moles, and also I saw concentration. 1.5 mole per dm cube is concentration, and they asked me to get volume. So which formula will I use? In that video I gave 5 formulas, so out of that 5 formulas I wrote, I'm going to bring out one, okay, which is numbers of moles is equal to concentration times concentration, okay, times volume. Now I want to check something. They are asking us to get volume, and if you observe, all the volume in the question was in cm cube, so it means that the volume we have to look for should be in cm cube, and whenever our volume is in cm cube, we always divide by 1000. Do you get? But if the volume in the practice question were expressed in dm cube, I will not divide by 1000. So next I cross multiply to check the volume. So I want to write volume in the short form, so volume will now be equal to N times 1000 divided by concentration in the short form as well. So what's N? 0.045 times 1000 divided by concentration, which is what now? 1.5. Okay, so let's press our calculator to get our answer. So this question is actually very easy. So 0.045 times 1000 divided by 1.5, that's 30. Okay, so the volume becomes 30 centimeter cube. Okay, so what option corresponds to that? Option B. Very easy. So let's get into the next practice question. Okay, here is the equation. They said C2H4 existing in gaseous state reacted with hydrogen gas existing in gaseous state as well to give us C2H6, and this is delta H. Delta H is called enthalpy change. It was negative. So then I said that the reaction represented is what? Now, whenever the enthalpy change of a reaction is negative, please take note, that reaction is exothermic. If it was positive, the reaction would have been endothermic. So the answer to this question is option A, exothermic. Exothermic. So moving further, tartaric acid is industrially used to make fruit juice. Okay, fruit juice. Take note. Now, moving further to the next question, which says the salt formed from a strong acid and a strong base is a neutral salt. Okay, you know, salts majorly they are neutral. We have other types though, but the first is a neutral salt. Now, the idea of planetary electron was that of, so they're asking who brought about the concept of planetary electron, the planetary model of an atom, which is also called the nuclear model of an atom. It was brought about by a scientist called Rutherford. Okay, not Thomson. Thomson brought about the plum pudding model of an atom, the plum pudding model of an atom, which has to do with positively charged matter. They are being embedded in a sphere, to which that sphere still contains negative matters as well. Okay, that's what this man was talking about. Okay, so but who talked about the planetary model? It was done by Rutherford, so Lord Ernest Rutherford. So 29 says, which of the following result in the fall of acid rain? It is oxides of sulfur. Okay, oxides of sulfur, they are responsible for what now? The fall of acid rain. So Question number 30 says metalloids are also regarded to be called semi-metals. Okay, semi-metals. So this must be noted. So moving further, the basicity of HCl is what? Very easy. This is HCl. Okay, so when we dissociate it, when we break it down, we form H plus what? Cl minus. Now, what's basicity of an acid? This is an acid. It is the number of replaceable hydrogen ion in one molecule of an acid, meaning that at the end of dissociating that compound, how many H plus did we get? If you check now, how many H plus can you see? Because it's balanced. H is here 1, another H is here 1. Chlorine is here, chlorine is here. So how many H plus did we get at the end of balancing the reaction? It is 1. So we say that the basicity of this compound is monobasic. Monobasic, or you can as well say it is 1. That's for that. So question number 32 says a basic soluble hydroxide is called an alkali. A basic soluble hydroxide is called an alkali. While question number next, which is 33, says the azimuthal quantum number for the d orbital is what? Remember, azimuthal quantum number is denoted with L, okay, and it describes what we call shapes of orbitals, okay, number of subshells, okay, which are orbitals. Now, look there, here are the orbitals, okay, we have the S, we have the P, we have the D, F, we have the G, we have the H orbitals. Now, all of these orbitals have their respective numbers and they are determined by the azimuthal quantum number, which is L. So the numbers ranges from 0, 1, 2, 3, 4, 5. Do you understand? And they're now asking us what is the value for azimuthal quantum number, which is L, for the d orbital. What value do you think it is? It is 2. Okay, so the answer becomes 2. Do you understand? D orbital is 2 for the azimuthal quantum number. So 34 says discovery of charge of an electron using the oil drop experiment was by which scientist? Was by a man called R.A. Millikan. Robert Andrew Millikan. Okay, so 35 says the two major allotropic form of carbon is diamond and graphite. Okay, diamond and graphite. Whereby 36 says a proton donor is what? A proton donor is very easy. A proton donor is called an acid, whereby a proton acceptor is called a base. Okay, this one is an acid. Here is a base, though there's a reason to this, okay, but just know it now. It's very, very important. And 38 says the shape of methane. Methane has a tetrahedral shape. A tetrahedral shape. A tetrahedral shape. So this must be noted about methane. But for question number 39, it says water has that shape. Water has a bent shape, a V shape, or an angular shape. Whereby for 40, it says the existence of two or more compounds having the same the same molecular formula but different structural formula, that is regarded to be called, it's a very important characteristics of organic compound. They call it isomerism. Okay, this set of compounds, they have the same molecular formula but they differ in structure. Okay, this is called isomerism. Though there is an explanation to all of these things said, but it's important for you to note them. Okay, so if you are just joining this community and you haven't yet subscribed to this channel, do well to subscribe. Share all of these videos with your friends. It's going to help you in the JAMB exam. Thanks for watching.